Okay, this should be the last one for the kind of radian measure section. I want to talk about two things. Arc length, which is, length of an arc, in particular an arc that's partway around a circle, and then area of a sector. I think you've done those before probably in geometry, but we want to do them kind of with respect to the angles we're doing. Remember that a radian, oi, okay, remember that 1 radian was the amount you had to go to get the radius as an arc length, okay? So every time I go 1 radian, I get 1 more radius on the arc length. So there are 2 ways you can think about it. One, you can just think about that and say, well, I went theta radians, so I went theta radii as an arc length. And this is it. This is your arc length, which I think in your text is called omega. So you just take the angle in radians, you multiply by the radius, done. It's possible you'll be given the angle in degrees, and then you just would translate it to radians and multiply by r. So in that case, if you're given some degrees, then you'd have to multiply first by pi over 180 degrees, and then by the radius. And this is all there is to arc length. The other way you can think about it is, well, the way all the way around is 2 pi r. I've got theta out of 2 pi. That's the proportion of the circle I will have gone. The whole circumference is 2 pi r, and now these cancel, and you still get the theta r. So you can think about it either way, and you can remember it either way. So this is your formula. Arc length, theta r. Once you're in radians, don't forget you have to be in radians. So if you're in degrees, you got to translate it first. So if I was told, oh, I want to know the measure of the arc length where my angle is, sorry, people are running around and being lunatics, and I'm not really sure what's happening over there, so I'm getting distracted. If you go, say, 7 pi over 9 is the angle, and you have a radius of 5, then your arc length is 7 pi over 9 times 5 is 35 pi over 9, and that's it. So unless you're looking at a multiple choice and you need to match it up to a decimal, in which case you got to put it in your calculator, this is it. So that's all you do for arc length. For area of a sector, it's slightly different. So the area of an entire circle is pi r squared, right? So if I have the proportion that I have is theta of 2 pi of the pi r squared, the whole 2 pi doesn't cancel. See, I just get to cancel the pi. So it's just, there's a 1/2 running around, so it's 1/2 theta r squared. So now if you're given the angle, I think it was before 7 pi over 9. So if you're now given 7 pi over 9, and you want to know the area of the sector it makes with radius 5, then 7 pi over 9, 5 squared, and you just need to add that 1/2 because in the formula for circumference you've got a 2 pi that cancels all the way out because all the way around the circle is already there. In the area you just have a pi, so you have half of all the way around. So half of the angle times 5 squared. So we get, let's see, 7 times 25 is 175 pi over 18. Okay, so this is area of a sector. If you were given, do one of each if you're given degrees. So let's suppose that instead you were given 40 degrees. The way that you might have done it in the past is to say that's 43/60ths of the circle, and let's say r is still 5. Okay? 43/60ths of the circle. The circumference of the entire circle is 10 pi. So this is still for arc length. And then 4 over 36 is 1 over 9, so 10 pi over 9. You would have put it in your calculator, I'm sure, and gotten a decimal. I still don't really want you to do that. So this is how you would have done it before. So the way that we'd probably want to do it now is say, well, I've got 40 degrees, but I want radians. So I want radians, and I want to cancel out degrees. So I put a pi there and a 180 there, and then I just multiply times the radius, 5. So get 4 over 18 is 2 over 9 times 5, 10 over 9 pi. It's the same, right? And really, the process is more or less the same, except that you only have to remember this conversion, and it gives you practice doing that conversion, which we want. Okay, so I'm still going to do 40 degrees, radius 5. And now I want area of a sector. So I need to first change this. So 40 degrees, canceling degrees, getting radians. It's the pi up here, the 180 down there. I still end up with that 2 pi over 9 that I had before, radians. So now for the area, it's 1/2 theta r squared. So 1/2 2 pi over 9 times 5 squared. So 25 pi over 9 is the area of a sector. Hopefully this is enough to get you guys started on that. So let me know if you need anything else.